Jessica Ladyada.
Hey everybody, it's me, Lady Ada. With me, Mr. Lady Ada behind the camera, and Baby Ada too behind the camera. So if you hear some jingling or cooing, she's learning how to talk and grab things. It's very cute. We just fed her. Oh, that's nice.
Say hi.
Okay, thank you. Lately, I've been holding her up and showing her my designs and asking for approval, and she goes, "Eh," so I know it's good. Okay, that's right. You're right. You are my new review engineer. Okay, at my desk this week. Well, we are cranking. Well, first off, is there any news from Mr. Lady? I just want to make sure.
Just keep an eye on all of our socials. We have a lot of articles coming out as the changing landscape in computing continues to approach something. The great attractor.
Yeah. Okay.
The singularity, perhaps. So watch that. We have a lot of cool stuff.
Yeah.
And we also have I'd say a full suite of new things that we're publishing. So if you want to see the latest...
Getting so much done.
If you want to see the latest Lego Smart Brick and some of the things we found with doing a Wireshark scan as well as other Bluetooth tools, neat. They did a good job. And then you can read articles about companies that didn't, like Life 360's Tile. Not a good job. So anywho, lots of neat stuff. Obviously, we're going to be doing cool stuff with Bluetooth. Nice to know what's good and what's not.
And like you're doing like Wireshark for Bluetooth with an LLM, which just saved you so much time.
I can't go back.
You can't. It's just like, look, guys, we know how to run Wireshark. We have run Wireshark.
I've done it
for decades.
I've done it.
I remember being like 18 and running Wireshark.
I've done it. I've done my time.
And we're done.
And I'm very happy just to say words. Hey, scan that brick.
Find the scan with this MAC address.
Scan that brick.
Okay, let's go to my computer. So I've been cranking through. So my desk has all the stuff on it, and over the winter, like I took a maternity leave. I'm getting back, and there's always like more stuff than you can ever get done. But I'm actually starting to chip away at this backlog, and a lot of it is thanks to my Ladyada PyClaw, which is my GitHub account, which is doing work on behalf of the install I have. So what I do is I make a library and it forks it, writes the code, does a PR, and then I review it. Maybe I'll show you a review that it's in progress. So for example, the Max 4409, this is a really wide range lux sensor. This library got done. I'll show the WF in a bit. The TMAG 5273, this has been on my desk literally since 2021. And it's always been like, I'll get to this 3D magnetometer. Cranked through it, did a great job. And I'm going to order and get PCBs for both the A1 and A2 version. There's like 2 ranges, so that's going to be coming soon. Better read me. The VCNL 4030, we talked about this. This is the replacement for the VCNL 4000 or 4040, which is like discontinued end of line. And I think on a previous great search, we found the 4030 was kind of like the best alternative. So also, like, I've written so many of these VCNL libraries. It was really great to sort of have my LLM do the vast majority of work. One thing is, there's like the first commit, which we do, and then what I do is I then start doing reviews, and I go back and forth with it, and I say like, hey, fix like the CI, this is broken. As I tested, I'm like, hey, once in a while there's an I2C read failure of OXFFF. I want you to skip or retry. So I'll go back and forth with it after like the chunk of the work is done. And then I'll do the review. So this is the PR. There's a massive PR, and I review the whole thing. And I test it, and then I go line by line. I find it still makes mistakes. I find all the issues, and then I merge it. So one thing that is currently in progress is the RV8803. It's an RTC. So right now there's a PR that's still open, and so I go through, and it's like 24 things. I review each file, and as I review each file, I check it off, and I say, okay, this has been tested. there's just like with it, RTC, it's just like annoying because you have to do a lot of testing with like remove the battery, put the battery in, like power cycle. It's a really power cycle. It's not. But I'll show some of these things over on the overhead in a little bit. The VCNL, the RV8803, the TMAG, that Lux sensor. Another thing I've actually having it doing it is it's doing the PRs for the library register. It can tag commits. Sorry, it tags releases, does the release, and then submits a PR. It doesn't always get it perfect, but it does a pretty good job. So here you can see the PR itself is submitted by Claw. So I don't even have to like do the whole like fork it, find alphabetically where it goes, then, submit it, do the PR, fix, any request it has. So it's been really nice just to have like some of this sket work that I used to have to do is now being done for me. And let me see. Oh, sorry, this folder. And then the TCS 3430, that's going to be in the store next week. And the TMF 8806, this is a alternative to, when this didn't get a release because I'm still in progress of testing it. This is a up to 5 meter time of flight distance sensor from AMS Osram. We have a lot of the ST, like ST has like so many time of flight, the VL 6180, 53.1, 53.2, 53.4, 53.5, 53.7L, whatever, tons of them. But I wanted to have an alternative. Another thing is, especially as we get to the multi-grid, like they do gridded time of flight sensors, the AMS Osrams are better, and also they don't require a firmware download, whereas the ST ones often do, and so they can't run on a small microcontroller like an Arduino Uno or like an original microbit or something. So it's nice to have an alternative. I like to have alternatives to the time of flight sensors. So then let's go to the overhead, and I'll show some of these in progress. So this is the, okay, great. This is seeing it. So this is the RV8803. So this is a alternative to the DS, God, what is it? The DS318, hold on, sorry, it's the Precision RTC, the DS3231. So the DS3231, fun fact, it's using an old process that I think is like no longer supported well at Maxim. And so they're really trying to get people to get like, it's like the Max 31855 or something. That's a thermocouple amp, but there's another similar precision temperature compensated real-time clock. But the DS3231 is like the classic temperature compensated real-time clock. And it's great, but it's big, it's chunky, and it's also kind of expensive. So this is really nice because this is the RTC. And what's nice is it's done by this company like Microcrystal. And what's funny is like they got really good at making crystals, and they're like, hey, we're so good at making crystals, maybe we should like make an RTC that uses the crystal. And it's actually probably easier for a crystal company to make RTCs and an RTC company to make crystals. So this is a whole RTC and temperature compensated crystal here. It's so tiny and small, and it runs on 3 volt or 5 volt, which is awesome. And then we have a little coin cell battery on the back for the real-time clock. It fits into my kind of standard 0.7 by 1 inch. So this is in progress. I'm just, making sure I get this correct. This is one of those, the TMF 8828. So this is, I think, 1 second. I'm sorry. This is an 8x8 gridded time of flight sensor. So it's kind of cool because you're starting to get to the point where it's like LiDAR-esque. Like you can actually start doing depth sensing. So it'll be cool. I'm looking forward to getting this working. Another thing that we're working on is this. This is like a low cost. This is the WF100DPZ. This is a low cost gauge pressure sensor. So most of the pressure sensors that we have in the store are like the BME 680, 280, BMP, DPS 310. I know, it's funny, isn't it? They're all named so similarly. But those are absolute pressure sensors. So they'll tell you like your altitude, because you'll be like, or your, the weather, because they'll say, oh, the pressure you're at is like, 1021 HPA, hectopascals or whatever. And, that means that your altitude is above, this much above sea level or below, or there's a storm coming, etc. This is a gauge pressure, which means there's these little holes that equalize the pressure. And so it's naturally at 0. And then as you suck or blow on the little tubing that I've like attached here, the pressure goes up and down. So go quickly to the overhead. Sorry, the computer. Let's see if I can trigger this to start. Although I just dropped everything. Okay, so at the computer, this is not. Oh, can you switch to the computer?
Sorry.
That's okay. The baby. Look, this is a very low cost sensor. So it says the temperature is like 27. It is a little bit warm in here, so that could be correct. And it thinks the pressure is 4 kilopascals. Now it should be 0, and as most sensors, you need to 0 point calibrate it. But then if I take this tubing attached to the sensor, I can get it to go up and down a little bit. So this could be good for, and this is good for touch sensors. Like people use this for robotics because the pressure, not maybe one of this range, because this is a very wide range, but a smaller range. Small changes in the squeezing of a balloon can be detected by this compared to the ambient pressure, and it will detect whether like the robots touch something. So this is, I've seen these a lot. Okay, and then back to the overhead, and I'll show the last thing, and then I think we'll do a time check. Last thing is I am going to get to. Liz has asked for very patiently for 2 years, hey, can you make a cutie pie quadrupler or whatever, so you can plug in multiple BFFs? And I'm like, I'm totally gonna get to that, and I keep not doing it. Sorry, Liz, but I did get to making this terminal block BFF holder, which also has a stemma QT. All of our boards have stemma QT, but if people have SHAO or they have other stemma QT pie / SHAO equivalents, they don't have an I2C connector, so I2C connector, and also a little battery charger, so that when you plug it in, here, and you get 2 rows, so there's an extra row over here, and then you also get the terminal block. I broke this off to test, but there should be a 4th mounting hole, and you can break these off pretty easily. You can run stuff off a battery, which I thought would be kind of nice. So this is also wrapped up and done. So you can see I'm really zooming through all the stuff. Trying to think if there's anything else. I'm still getting to the GPS stuff. I'm doing that. Lots of sensors going to be in the store next week, so look forward to that. STCC4. That's a indoor air quality CO2 sensor, and the TMP 1119 or 119, which is the ultra precise temperature sensor. So looking forward to that as well. Okay, cool. Yeah, that's going to be good stuff. So you'll see about 2 designs per week on average. Getting back to that, I used to do 1 design a week, and then I was starting to get to 2. Now with all my claws and LLMs, it's 2 is easy. And
she's hyperscaling, folks. Stand back.
You might see me sometimes have 3 or 4 products a week, depending. Especially if there's variants, for this this gauge pressure sensor, I'll probably have a couple different configurations. Okay, how are we doing on time?
We are up to 14 minutes.
Perfect. Let's go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you so much, DigiKey. Every single week, Ladyada is our power of engineering to help you, yes, you, find the things you're looking for. Ladyada, what are we looking for this week?
Okay, let's go to my computer. This week, we've gotten a bunch of requests about the ICS 4343434. I don't know. To concatenate how many 4s and 3s you need. This is I love this I2S MEMS mic. We actually use it on a lot of boards. It's kind of all in one. You give it 3-volt power, and it just pipes out microphone signal, which is great. This is a bottom port, so you turn it upside down. I think it's digital pins. Right, sorry. The microcontroller controls the clock, the bit clock, and the left-right clock, the word select, and out comes data via the D out based on the microphone. You can have two of them, and then you have one with cell low, one with cell high, so you can have stereo mic. You don't need a codec, no I2C configuration, no like crazy wiring, no electro mic. It's pick and placeable. It's, it's not washable because there's a port, but it's been a great little chip. Unfortunately, if you go to DigiKey now and you're like, great, I want to buy this, it just went last time buy, like 2 weeks ago. And so a couple people are asking me, hey, really like this I2S mic. You use it. What are you going to use an alternative? And unfortunately, the other alternative I had been using, the SPH and something, is also end of line, which is really a bummer because, again, I know, it's very sad. I really love this mic. So they recommend, DigiKey recommends this MMICT 5837. This is, I'm sure, a very nice microphone, but it's PDM. So watch out for that. A lot of times digital microphones are PDM, not I2S, and they're a little less expensive because of it. You have to spend more to get I2S output. Again, it's kind of an unusual thing, but I really love it. So this is kind of cool though. It has an ultrasonic mode. We will probably have a breakout for this sensor because it is a very cool sensor, but it only has clock and data out. You need to have a PDM receiver that can convert that into I2S. And there's chips that do it, but now you have another chip. So let's go back to here and select, we want I2S digital. And it says 10 options. And then what if we select MEMS, just in case it also says 10? Okay, so that's good. Let's, we don't want to do the part status last time buy. We were going to see what comes up. 10 is not that much. And we see a couple options. So looking at the product status, let's drag this over. I don't really care too much about tariff status. Okay. So looking at the active status, you'll see a lot of these are obsolete. This is the SPH 0645. I was using this. It's a great little sensor. There's still a lot in stock, but it is last time buy obsolete. This is that thing we were just looking for, obsolete, and then these are not active or stocked anymore. So let's go and click on normally stocking. So look at all the ones that are going to be available long term. And this is it. Not a lot of options. So one is the MICT 5848. So this is not the 47. We just looked at that 47. So the 48 is an I2S microphone, but it looks pretty good, 27 to 18 kilohertz, but it's 1.8 volts only. Does that matter? Maybe to you it doesn't. Maybe you're working with something with 1.8 volts. But it means that if you're using this with 3.3 volt logic, like most microcontrollers, ESP32, your Raspberry Pi, you're going to be out of luck because those tend to run on 3 volt logic. And then once you have logic shifting, okay, now, it's the price and the size is doubled. So the next option, this one is marketplace. So it's like going to be somewhat, you can get it, but it's not in stock right now. The other alternative is this DMM 426. And this one is from PUI. This is also, this is rated voltage 1.8, but you can run it at 3.3. And it does I2S output. And it looks pretty good. It has the same setup as before. You can have 2 microphones if you want. It goes up to about, it's not perfectly linear as normal because it's a small mic. Looks like it's good from about 20 to 18 kilohertz. It probably has a slightly different pinout, but you can check it out. But this is the one thing available. The price is good, less than $2. So I'll probably end up making a breakout board for this as an alternative to that ICS 4343. Now, last time buy usually means you can get it for like another year or so. But if you're designing something now, I would definitely use this chip, this microphone instead. And as your old designs have to get revised, or if you can, try swapping it out for this one. It's got a slightly different response curve, but hopefully good enough. You can make some tweaks to your firmware or software and get it running. So this is my pick for the great search.
That was a great search.
Where in the world is that part I need? The great search with DigiKey.
That's our show.
I know. Great.
Easy peasy lemon squeezy.
We're back. Welcome, bullshit.
Multiple children, multiple products, no crying, break time's over. We are merging with the machine.
And it's springtime. I'm loving it. I'm
Yeah.
so excited to now, like, it'll be so much fun to be like, we're going to be out at the park with the kids and we'll be on like our Telegram and be like, hey, can you reverse engineer this binary? Hey, can you download this data sheet?
Yes.
It's a totally new world. It's
Yes.
really amazing.
There is a lot of change ahead. It's going to happen whether you want it to or not. That's how time
Yeah.
works. It's possible to figure out ways to enjoy the journey. See y'all next week.
Yeah. Thanks, everybody.